Professor Maraj is ensuring that we stay on track with time. So our next presenters are actually three of the presenters or the researchers in a multi-researched project. So the presenters will be Miss Nalini Duki, Miss Sasha Ramkilawan and Mr. Zafir Mohammed, and they are from the Department of Physics, Faculty of Science and Technology, and they will be speaking on sustainable futures, building resilient communities through health, infrastructure, and clean energy. There's a microphone there if you want to move, or you could stay at the podium. Okay?
Director of Graduate Studies, Professor Dhirasamy Saravana Kumar, Acting Dean of FSD, Dr. Ricardo Clark, staff and students, good morning. We are extremely honored to present Sustainable Futures, Building Resilient Communities through Health, Infrastructure, and Clean Energy, winner of the Best Team Research category. I am Sasha Ramkilawan, and I am accompanied by Mr. Zafir Mohammed and Ms. Nalini Duki, representing our 10-member multidisciplinary research team.
You can hear me? This good? Yeah? Our project aims to advance sustainable development and climate resilience in the Caribbean region by integrating multidisciplinary research across various projects whose key focus areas are renewable energy and just energy transition, modeling sustainable food security pathways for cocoa production, expansive soils and infrastructure resilience, epidemiology and disease prevention, and water resource management. This project aligns closely with the United Nations Sustainable Development Goals to end poverty, protect the planet, and ensure that by 2030, all people enjoy peace and prosperity.
Based at the Department of Physics, our team consists of 10 core members. There are 2 faculty researchers, 1 associate researcher, 5 PhD candidates, and 2 MPhil candidates. The team members have varying research specializations that are all in alignment with the SDGs. My colleagues and I will now go into some more details on the team's research on advancing the SDGs.
One area of focus is to ensure infrastructure resilience. This project is led by myself, Zafir Mohammed, which aims to address the challenges of expansive soils in Trinidad. Expansive soils cause billions of dollars of damages globally to infrastructure worldwide. In Trinidad, these soils exist in abundance in the central and southern region of the island that causes damages to our infrastructure. We address this by developing predictive models which we use to upgrade and refine existing soil expansion maps. Thus far, data collected from 65 soil samples revealed that soils from northern Trinidad have low swelling potential, while soils from central Trinidad have low to medium swelling potential. Also, international standards may not be suitable for classifying our local expansive soils, thus highlighting the need for a localized classification system. By classifying expansive soils in Trinidad, this will aid in foundation design, which will reduce infrastructure damages and reduce repair costs. This project is done in collaboration with the Faculty of Food and Agriculture and is in alignment with SDG 9, Industry, Innovation, and Infrastructure.
An essential element to sustainable development is ensuring the availability and sustainable management of water. This was addressed by Dr. Charlene Bihari, for which she was awarded her doctorate in 2022. Dr. Bihari established a hydrological model to estimate water volume at the Navet Reservoir and estimated future reservoir volumes under different climate change scenarios. The key findings of this research were that there were 3 distinct areas of drought variability identified in northern and central Trinidad, and that the lowest reservoir volume is expected during the period 2041 to 2070. These findings could be used by stakeholders to identify potential water shortages, allowing decision makers to implement appropriate measures to properly manage water resources for such situations. This project was done in collaboration with the Water and Sewerage Authority of Trinidad and Tobago and the Trinidad and Tobago Meteorological Service. This project aligns with SDG 6, Clean Water and Sanitation.
Food security is a fundamental pillar of sustainable development. acknowledging that Trinidad and Tobago competes as a 100% fine flavor cocoa producer and that traditional open-air methods of drying poses challenges due to unpredictable drying conditions. This project, led by Ms. Priscilla Sahadeo, aims to improve quality of cocoa by developing suitable drying regimes. The main objectives are therefore to monitor drying rates at different locations in Trinidad, to explore various solar drying techniques, and to evaluate local drying kinetics. Thus far, from data that was collected, it was found that considering intermittency in drying lengthened the drying process, however, it yielded a higher quality cocoa. Ms. Sahadeo's work contributes to improving local drying regimes to reduce losses and enhance cocoa quality. This project is done in collaboration with the Cocoa Research Center and local farmers and is in alignment with SDG 1, 2, 7, 8, and 12.
Switching the focus to health, which is another important area for sustainable development, this project is being led by myself, Ms. Sasha Ramkilawan, and supervised by Dr. Ricardo Clark and Dr. Andrea Joseph. The focal point of this study is the reduction of cardiovascular disease, which is the leading cause of death globally and locally. In this study, known and potential risk factors for cardiovascular disease identified by clinicians and researchers worldwide are being investigated locally, and a tool for the identification of high-risk individuals is being developed. In one of the studies that we conducted using data from a local private cardiovascular facility, it was found that the prevalence of risk factors differed based on age and sex. So for example, hypertension was found to be more prevalent in elderly, while risk factors such as high cholesterol and family history of heart disease were found to be more common in males as opposed to females. This research also develops a risk score for cardiovascular disease, which is currently outperforming other similar scores when used on this population. This research is expected to contribute to the reduction of CVD mortality in Trinidad and Tobago, to the decrease in CVD-related healthcare costs, and to the promotion of healthier lifestyles and behaviors in this population. The key collaborators for this project are the Eastern Caribbean Health Outcomes Research Network Cohort Study and a local private cardiovascular institute. This project aligns with SDG 3, Good Health and Well-being.
For small islands, such as ourselves, the inclusion of renewable energy as an alternative for power production is a crucial element of a country's sustainable development plan. In our group, we have multiple researchers conducting a variety of solar and wind projects. These projects include wind and solar resource mapping, resource modeling, climate change, and energy demand modeling. The technical, economic, and environmental feasibility of projects are assessed. Some assessments included energy just principles. Through these combined efforts, we have seen a reduction in a project's uncertainties and risk, therefore improving a project's bankability and hence increasing investment potential for solar and wind projects. This information can feed directly into decision-making and policy directives. Dr. Zita Shady led the creation of maps of wind resources at different heights in Trinidad and Tobago for wind farm siting. The project found utility-scale wind farms to be feasible, both onshore and offshore at the hub height of 100 meters. Model wind data was validated at the 10-meter height, and work is ongoing on validation at other heights. This work was conducted in collaboration with the International Center for Theoretical Physics in Italy. The second wind project, led by Mr. Mohammed Shadi, focuses on measuring the vertical wind profile of the atmosphere to improve the accuracy of wind resource assessments and reduce their uncertainties. The work is done in collaboration with the German University of Flensburg and the Swedish AQ Systems. This project provides reliable data to support sustainable wind solutions. Ms. Nakisi Makshine leads the modeling of the effects of climate change on the wind resources for small island developing states within the Caribbean region. The project includes a collaboration with the Caribbean Institute for Meteorology and Hydrology. This information is crucial because changes in our wind resources for the future will affect the energy output of wind turbines and in turn, revenue streams. Turning to solar, one of our projects looks at PV project feasibility. This project, led by myself, Nalini Duki, includes a strategic partnership with Trinity Exploration and Production PLC and the Trinidad and Tobago's Meteorological Service. Pre-feasibility assessments of utility-scale photovoltaic systems in Caribbean islands with limited renewable energy infrastructure were conducted. To further support islands with limited data, a simulation tool was developed. Work on creating and improving data models to reduce the solar resource risk in feasibility assessments are ongoing. By minimizing the risk traditionally associated with PV projects, especially in regions in the Caribbean with limited solar data, improves the foundation for decision making. Mr. Randy Ramadasing is a project lead for the Just Energy Pathway project. This project considers potential transition pathways for Trinidad and Tobago. It included modeling renewable energy onto our national grid. The results, for example, included a 700 megawatt PV facility. It was found that with this facility, we can have a result of over 20 million MMBTUs of avoided natural gas. This volume of gas can then be sent to the Point Lisas estate, which currently needs more natural gas. Such sales can translate into annual savings for the state of over 87 million US dollars. This project led to the development of the Prosperity Post-Fossil Fuels Policy Framework for Trinidad and Tobago, with Mr. Ramadasing as a Salzburg Global Fellow. The work further led to the completion of a Just Energy Transition Draft Policy for Trinidad and Tobago to be presented at COP29. This project has included the collaborative efforts of the Salzburg Global Seminar, the Government of Trinidad and Tobago, multiple ministries, TNTEC, and the Trinidad and Tobago's Meteorological Service. These combined renewable energy projects promote SDG 7, affordable and clean energy, by increasing access to renewable energy, and supports SDG 13 on climate action through providing information on low carbon investments. By providing just pathways to clean and affordable energy, we're not only just addressing SDG 16, but also SDG 1, energy poverty, and SDG 10, reduce inequalities, by empowering vulnerable communities. This, in turn, contributes to fostering an environment where communities can thrive sustainably and justly. Peace, justice, and strong institutions are further supported by encouraging transparent and equitable investments in infrastructure that benefits society.
Over the last 5 years, our team has produced a total of 16 publications, all related to the Sustainable Futures Research Project. 11 of these were journal articles, all published in peer-reviewed journals from publishers such as Elsevier and Springer, with impact factors ranging from 2.3 to 9.0. 2 of these were conference proceedings. Another 2 were technical reports produced in collaboration with organizations such as CROSQ and the Government of Trinidad and Tobago. And lastly, one of these was a policy briefing titled Prosperity Post-Fossil Fuels.
Given the multidisciplinary nature of our team, we have employed numerous creative strategies to ensure coherence. Firstly, the team hosts weekly internal seminars where we present findings, important ideas, and problem solving. When a member attends a workshop, a teach-back session is usually held where that person disseminates the knowledge learned to the wider team so we all benefit from the workshop. We also use cloud-based data repositories to store, share, and view information in real time, regardless of our location. We often have off-site retreats that prevent burnouts, and our open plan lab encourages spontaneous collaboration, knowledge sharing, and collective problem solving.
The Sustainable Futures Project highlights the power of interdisciplinary research in tackling global challenges. Okay. We have key collaborators that includes the government and international stakeholders and industry. And we would like to acknowledge those collaborators as shown on the screen. Thank you very much.
Thank you, everyone.
Thank you very much, Ms. Duki, Ms. Ramkilawan, and Mr. Mohammed. Any questions? There's a question here.
So you hear me, right? Okay. Yeah, right. So it's kind of like two questions in one sense. The first question, which is researching wind and location in Trinidad, I want to know how far along are you in terms of when it comes to putting in these windmills?
Could you just speak up a bit?
Sure, no problem.
Yeah.
Sorry. In terms of putting the windmills on the north of Trinidad, I think that's where you said you wanted to do that? I'm just confirming one thing.
No, we are
No,
doing wind projects.
Right.
Yeah, one of the projects and found that we looked at the feasibility of wind farms throughout the country,
Right.
and another one looks at modeling the vertical wind profile of the atmosphere.
Right. Okay. Okay.
Yes.
Thank you. Right. That's really just what I wanted to clarify.
Okay, no problem.
Any other questions?
Okay.
Okay. Thank you very much for your
Thank you.
contribution and your research. And I'll hand over to Professor Maraj.